and have less of the Zoom and more of in person, and I can see you guys. And I'm so ready. I don't know if you are or not. So I'm doing problem 11, and I want to move on to the optimization right after that. So this little guy bug is located here. And then he has the, so that's a point. And it's going toward 5 and 7 and 3. So begins here, start, and then this is the function of its temperature on its road. He's just trying not to fry the poor bug. And so the first question is asking, at what rate is the bug's temperature changing? This is moving, right? There's a direction. What direction would that be? This is the direction, right? So the direction is 5 minus 3, 7 minus 9, 3 minus 4. And that's 2, negative 2, negative 1. So that's the direction he's going. The bug is going. It is going. Now the question is, what does it mean? At what rate is the temperature changing? We're asking for the directional derivative, right? Let's just add that direction. It is a directional derivative. It's directional derivative question. So it is a directional derivative. Directional derivative makes sure the direction is a unit vector. The formula that we got with the dot product, direction has to be, and it has to be the direction. Don't go with the points. Go with the direction. Direction is that, and make it a unit vector. So what do I do? Unit vector, I have to compute. This is, let's say this is V. I have to find the magnitude of V. And that's square root of 4 plus 4 plus 1. Square root of 9 is 3. So the direction, the unit direction is 2 divided by 3. 2 divided by 3. Negative 2 divided by 3. Negative 1 divided by 3. Okay, so that's step 1. Now, step 2, compute the gradient vector. Gradient of t. Can you still see the function up there? Yes. So, gradient of t, partial with respect to x first. See, it's x times e to the power whatever is just a constant. So it would be e to the power whatever because that's a constant coefficient. So this is partial t sub x. Now, t sub y. X is the constant coefficient. E to the power y minus z. Z is like a number. So it's e to the power y minus, so exponentials, I know it's going to be itself times the derivative of inside. Derivative of y minus z with respect to y is going to be 1. So that's the partial with respect to y. Now, partial with respect to z, x is a constant. Now, e to the power y minus z again, outer function itself, with the inner untouched. Then y minus z with respect to z is negative 1. Found the gradient. Now step 3, evaluate the gradient at the point that the bug starting to walk. What is that point? 3, 9, and 4. So 3, 9, and 4. Somebody ask a question I can't hear. Up or down? Okay. Now makes sense. Okay, thank you. So now it would be e to the power 9 minus 4. And then 3 e to the power 9 minus 4. And minus 3 e to the power 9 minus 4. E to the power 5. 3 e to the power 5. And tell me if I'm doing horrendous arithmetic level. Now, found 2 open vectors, that and this. What is remaining is 2 dot product. Can I still write here? Would you guys be able to see it if I write over here? So the directional derivative in direction u of f at point, what was the point 3, 9, and 4 is going to be a gradient of t, not f, dot u at that point, and that is what? 2/3 e to the power 5 minus 2/3 times 3 e to the power 5 minus 1/3 times minus 3 e to the power 5. And you can simplify this and it would be one expression. What would it be? Now I want to know. This one is 1. That one is minus 2. So minus 1 plus 2 minus 1/3 of e to the power 5. Sorry, got messy at the end. So that said, part B of the same question is asking at 5, 7, and 3, what is the directional temperature? Sorry. Yeah. As soon as you can't touch your face, itches all over. What is it? Is it Murphy's Law? Okay, so I'll start here. And so I want to figure out what direction is the temperature increasing the fastest. 5 and 7 and 3. Oh, they're locking the door. We can't get out, but nobody else can come in. And so fastest increase, it should be in direction gradient of t. So gradient of t is equal to e to the power 5, 3 e to the power 5, and then 3 e to the power 5. You can basically normalize this, or I'm sorry, find the unit vector by dividing by the magnitude. But since it didn't ask for at what unit direction, this is good enough. Now, what is the maximum rate of change? That you have to find the gradient of t. No, I'm sorry, magnitude of gradient of t. And that would be square root of e to the power 5 to the power 2 plus 9 e to the power 5 to the power 2 plus 9 e to the 5 to the power 2. And that is what? 9 plus 9 plus 1 is 19. e to the power 10 square root of 19 e to the power 5. Okay, so that was part B. Let's do part C. Part C, the direction is negative gradient of f, because what direction are we decreasing fastest? Just multiply by negative sign. And the rate is also negative of the magnitude. So fastest decrease is just negative of the gradient direction, and so far so good. Are you with me? Ask. Sorry.
For part B and C unit, that point, we still use starting point.
Was it the point was the same, right? I didn't make an error in there.
That question is asking what's the first
Oh, point is changing.
Yeah, it asks if the second.
Absolutely sorry. I didn't pay attention to the point changing. What I did is I found this. Darn it. Zoom, did you hear me? I made an error in here. I didn't compute. I thought this was the same point. These values are not B and C. These are B and C if the point was 3 and 9 and 4. Right? So let's do B and C quickly. I know the gradient vector is what? Is it up there? Let me write down the gradient vector. Gradient vector was this, e to the power y minus z, x e to the power y minus z, negative x e to the power y minus z. Let's do this correctly. And now I'm trying to compute that at 0.5, 7, and 3. So if I plug in gradient of t at 5 and 7 and 3 is going to be e to the power 7 minus 3 is 4. 5 e to the power 4, negative 5 e to the power 4. So E, that's the direction. And the magnitude gives me the rate. E to the power 8 is 25 e to the power 8 plus 25 e to the power 8. That's square root of 51 e to the power 4. Okay, did I make any error? I think this time I got it. And so C, the direction is negative e to the power 4, negative 5 e to the power 4, and 5 e to the power 4. And the rate is negative square root of 51 e to the power 4. Sorry about that. Now, I am trying to do a chain rule and an optimization, and 2 optimizations. Is it okay if we stay another like 20 minutes? Is this okay with everybody? Let's stay 20 more minutes and I do one of each. One problem of each. And so oh, done. So chain rule, I really suggest doing the for chain rule, trees are helpful.